Hello everyone, welcome back to the new video on my channel Corrospective. Today I will talk about the copper alloy specification that is used in marine heat exchanger. A marine heat exchanger can be of two different types, one of which is the straight tube heat exchanger. In such a component, the tubes and the tube sheets have various kinds of materials used for their construction so as to facilitate an efficient transfer of heat from one fluid to the other. Today's topic is specifically about the tubes which are made up of 90-10 and 70-30 copper nickel. As you can see here, the design temperature and pressure has been specified for the shell side as well as the tube side, which means that the materials which are used for the tube and the tube sheets have to be able to sustain the temperature and pressures given for the tube side, and those which are provided for the shell have to sustain the temperatures for the shell side. To get an idea of what actually happens to these alloys in the specified temperature, it is a good idea to look at the equilibrium diagrams for copper and nickel. Here it shows the variation of temperature versus the variation of the composition of nickel. With respect to the composition of nickel, the phase which is present in that alloy will change. For a 90-10 copper nickel, the alloy lies somewhere around this area. For a 70-30 copper nickel, it lies somewhere around this area. Temperatures, the microstructure that is resultant from these differing alloys depends on the phases present in that particular alloy. This equilibrium diagram is up to only 200 degrees Celsius, but even at this point the phase present is a solid copper nickel. At the 70-30 copper nickel, we see some semblance of a transition between the alpha 1 phase and the solid phase. Hence the microstructure at 70-30 would probably be different from that at the 90-10 alloy. A typical copper metal has a face-centered cubic structure which looks something like this, with atoms of copper in the center of the faces as well as at the edges of the faces. When you have addition of a nickel atom in this particular structure, it goes and sits in the positions held by copper in a substitutional form of solid solution forming. Hence, for a copper nickel alloy of 90-10, you will have nickel present in certain areas, while for copper nickel in 70-30, you will have nickel substituted at a higher number of areas in place of copper. When we look at this structure in a microstructural point of view, the lamellar form in copper nickel 90-10 is usually much different than that in 70-30. Such a difference in lamellar form gives rise to difference in the grain boundary structures as well, which would contribute to the differing mechanical properties and physical properties which are seen for the copper nickel alloys and which are used for the selection of their heat exchanging properties. When we look at this microstructure from an electrochemical point of view, it is really important to go to the very basics as well as to the specified material. This is a marine heat exchanger. Hence, it is necessary to look at it from the point of view of galvanic series as well. If we look at just the electrode potentials, which is the ability of those particular elements to exchange electrons, the copper has a potential of plus 340 millivolts, while nickel has that minus 260 millivolts. Even a look at these two potentials shows us that there is a potential difference between copper and nickel, and hence there may be a galvanic coupling if they are present next to each other in the lamellar structure in the form of different phases. Now when we look at the alloys, we see that in a galvanic series, the 70-30 alloy has a 91 to minus 1 millivolts, and 9010 has a 41 to -9 millivolts, which are hugely different from those seen for the electrode potentials. Hence, the electrochemical characteristics that are seen for copper nickel will depend on the microstructures and solid solutions that are formed from these two elements. Also, it is more important to check for the electrochemistry from the point of galvanic series rather than from just the electrode potentials. It is also notable that the composition difference also gives us a difference in the potentials as well. Hence, if someone has used a 70-30 copper nickel alloy for the heat exchanger and has seen corrosion in a certain environment, it is not necessary that he will see the same amount of corrosion in 9010 copper nickel alloy. He may see more or less corrosion depending on the composition of that particular alloy. This is a typical example of water quality requirements. Here you see that there is a pH given for different temperatures and properties of water. If we take this quantity of pH and overlap it with the electrode potential of copper, we get a plot called the pore base diagram. Here you can see that with respect to pH and potential, the form of copper present in that particular element will change. If we just take the example of electrode potentials, then at plus 340 at the pH of 7 to 8, we have some semblance of a copper oxide. If we take the example of the galvanic series, it is not really applicable to pore base diagram, but I would just like to take the example because here also the copper is the element which will form the compounds when corrosion occurs for these alloys. Hence, for a potential of 91 millivolts and for a pH of 8, the compound that is obtained is in the transition region between copper hydroxides and copper oxides. Hence, for the materials showed in the previous water quality requirements, even if there is a small change in the pH, it will lead to a change in the compound formed by the copper in response to the environmental exposure that it is given. Further, if suppose the alloy has now changed to 9010 copper nickel, then at 41 millivolts the element will lie somewhere around near 0, and at a pH of say 8, it will lie wholly in the zone of copper oxide. Hence, the corrosion products or the corrosion tendency that is seen for these two alloys will be different, and a failure analysis of the heat exchanger tubes for these copper nickel alloys should include a look at the pore base diagram as well as the material chemistry. So this was all about the copper in heat exchangers. If you need any more information, please do get in touch with me. Do check out my channel for more. Do like, comment, share and subscribe, and please keep a lookout for the next video. Thank you.